So I'm going to talk about UFPs. It's not a very new pollutant, not as PFAS, of course, but it's still emerging. And the step between laboratories and field is usually quite difficult, and there is a lot of problems to solve, and that's what Envea is trying to do in this case on the UFPs. Okay, so UFPs, I think most of you know what it is. So it is a very fine particulates below 1 nanometer. Usually the definition is about that. And of course, because of their size, their mass contribution is extremely small, but the quantity of particulates is extremely high. So that's why we are moving from milligram or microgram measurement type, which is the norm in ambient air, to the counting particulates. And you can see the kind of concentration you can have depending between the urban situation or the rural situation, from thousands of particulate per centimeter cube to 50,000 or even more millions, for example, nearby airports, extremely high concentration of nanoparticulates. Okay, so that's why the particulate matter monitoring that is currently implemented by the standards using microgram is not relevant for the nanoparticulates. So another standard has been implemented, and other technology are also requested to be able to do this monitoring. Okay, so as probably most of you know, the existing technology for PM2.5, PM10 do not work for nanoparticulates. For different reasons. The beta gauge, which is a, let's say, more usual technology, is limited by the filter's mesh size. So of course, the nanoparticulate will get through the filter and cannot be measured. And even if it were, the weight technology is not able to detect that low quantity of mass in a filter, even of a 24 hours cycle. And for the more recent technology of light scattering, because we are using visible source or near infrared source, you cannot see nanoparticulate because it's too far from the wavelengths of the source. It would require maybe a far UV source or even X-ray source, which is not practical. So the best counter that you can find usually can see particulate down to about 200 nanometer, and that's twice above the maximum size you want to see for a nanoparticulate. So you need something else, you need another technology. And this is very important for a large number of applications. This nanoparticulate has been implemented into the automotive industry for quite some time already for the Euro 6 and Euro 7 norms. More recently, it has been implemented in the new European directive for the superstation as a emerging pollutants to monitor. It's been monitored by Actris networks already for a while also. And it's been also interesting for other applications, of course, ambient air around airports and harbors. Airport has a very, very high level of nanoparticulates, and other applications like clean room, for example, in semiconductor, because of the size of the microchip is going down, so the size of the particulate you have to monitor is becoming also smaller. So nanoparticulates become a big problem in some of the facilities. Okay, so how we measure UFPs. So the main principle is the CPC, condensation particulate counters. And you can see the transition here from the, let's say, traditional technologies up to 200, 300 nanometers to the CPC technology here, and you can go down to 10 nanometers with the traditional CPCs, and you can go a little bit below, down to 1 nanometer with the additional amplifier. So you can really get almost to the gas level. Okay, and so this CPC is a baseline of the technology. This is what is given by the European standards to measure nanoparticulates. So it's very accurate. You can get to very low level of particulate, but it cannot differentiate size. And you have also an additional electrical mobility device you can add to size the particulate, and then you have the CPC to measure the quantity. But I will focus on the CPC today because this is a standard, and this is what is going to be filled more likely in large number in the future. So I wanted to focus on some operational problems and difficulties that customer and user may face, and that Envea wanted to solve as soon as possible. Okay, so the CPC is meant to, actually a particle counter, so not unlike the traditional optical counter you can see for PM2.5, for example. But of course, the nanoparticulates are too small to be counted, so you need a nucleation step to grow this particulate by passing the particulates through a supersaturated gas that we condensate on the particulate and grow them in the micrometer size so that the counter can see them. So because you want to inject the particulate to a supersaturated gas, you need to inject a gas, and there is a very important choice of which gas, which molecule you want to use to make this condensation. And the more usual one is N-butanol. So this is the one mentioned in the standard as a normal, of course, gas, and other are also allowed if they are equivalent. But if you look at all the publication and all the product available, they are all using N-butanol. Okay, so this is a quick graph of the system. So you have the initial chamber where you inject the solvent and you heat, so you saturate the gas. Then you lower the temperature so that you're coming to a super saturation status, and then the gas will condensate on each nanoparticulate so that it's reach a few micrometer size, and then the counter will able to count the particulate. So relatively simple principle. Okay, and of course, this kind of particulate is defined by the size, the minimum size that you can count from, so which is a 50% cutoff. So usually the standard in Europe is set at 10 nanometers. So that's why most products now are designed to work from 10 nanometers. And it can go up to usually 1, 2 micrometer, 2.5 usually, but it doesn't matter because the number of particulates is very small. So you can go to 1, 2, or 3. The result, the counting result will be very similar. Okay, so there's two challenges for the CPC to be filled in larger quantities, which is likely to come in the futures, especially after the certification body will be able to run Qual1 on those equipments. First one is to run QA/QC on the field. That is a general challenge for all the equipment.